Now, in this video, we're going to take up one more case of comparison of weight of hollow shaft and the solid shaft. So first, we're going to consider a hollow shaft and a solid shaft of the same material, length, and the torsional strength. As the torsional strength, we say T by J, T by tau will be equal to J by R, which is equal to ZP. So that means torque divided by the shear stress will be equal to the ratio of polar moment of inertia and to the extreme radius. So that will be equal to Zp, which is the section modulus. So as the torsion strength of the shafts are equal, so what happens? Jp by R. So that means Zps will be equal to Zph. That is the sectional modulus of the solid shaft will be equal to sectional modulus of the hollow shaft. So what is the sectional modulus of the solid shaft? It is pi d cube by 16. So that is because Zp will be equal to Jp by R, which will be equal to pi d to the power of 4 by 32 divided by d by 2. So pi d cube by 16 is the value. So that will be equal to pi by 16 into d naught to the power of 4 minus di to the power of 4 by d naught. So pi by 16 will get cancels. Therefore, d cube will be equal to d naught to the power of 4 minus di to the power of 4 by d naught by d naught. So taking d naught to the power of 4 as the common factor into 1 minus di by d naught, the whole to the power of 4 by d naught. So where k will be equal to d by di by d naught. So that means on simplification, d cube will be equal to d naught cube into 1 minus k to the power of 4. So since it is d cube, so d will be equal to taking the cube root, d naught cube root is d naught into cube root of 1 minus k to the power of 4, where k will be equal to di by d naught. So what will going to be the weight? Weight will be equal to volume into specific weight of the material. So volume is area into length into specific weight of the material, which will be equal to capital A into small l into small w. So weight of hollow shaft divided by the weight of solid shaft will be equal to WH by WS will be equal to AH into LH into WH small wh divided by capital AS into length of the shaft into solid shaft into specific weight, which is W small ws. So on simplification, as we know, LH is equal to LS and small wh will be equal to small ws, which will be equal to AH by AS. So once you get that, we have the equation that is substitute the area of hollow shaft as pi by 4 into d naught square minus di square divided by area of the solid shaft, which is pi by 4 into d square. So that means once you are taking the common factor, pi by 4 get cancels and d naught square into 1 minus di by d naught the whole square divided by d square. So substitute the value of di by d naught as k square. Therefore, d naught square into 1 minus k square divided by d square, where k will be equal to the ratio of the internal diameter by the external diameter, which is di by d naught. So then once you take that, you can take that it as d naught square into 1 minus k square divided by what is d square. D square is nothing but d naught square into 1 minus k to the power of 4 whole to the power of 2 by 3. So therefore, which will be equal to d naught square, when d naught square get cancels, which will be equal to 1 minus k square divided by 1 minus k to the power of 4 whole to the power of 2 by 3, which is always the ratio is less than 1 because the denominator is greater than the numerator. So therefore, naturally, the ratio will going to be always less than 1. So where d will be equal to d naught into cube root of 1 minus k to the power of 4. So therefore, from this what we can infer is the weight of the hollow shaft is less than the weight of the solid shaft when their material length and the torsional strength are same. So this is how you will be able to compare between both the hollow shaft and with that of the solid shaft. Thank you.